Hi, my name is John Conlin,
My name is Aimufia.
and our project is tailoring post-curing methods to enhance mechanical performance of a BCC metamaterials fabricated using stereolithography. Our abstract states that mechanical metamaterials are becoming the center of attention in industries where ultra-lightweight materials with high energy absorption are desired while being able to keep their enhanced mechanical strength. These metamaterials are artificially engineered structures that are manufactured from periodic geometric patterns. This research purpose is to design body-centered cubic unit cells and subsequent metamaterials as it offers lightweight structures while ensuring better mechanical performance. Designing these metamaterials with traditional manufacturing processes is quite challenging. Additive manufacturing, or AM for short, can achieve enhanced manufacturing complexity with increased customization level due to its layer-by-layer manufacturing process. Even though that this AM technology is promising, it is not uniform enough for their solidification of the printed part, and this results in poor mechanical performance. To address this, the research aims to study on 3 different post-curing methods, such as UV waves, oven heating, and ultrasonic waves. In our background, we will be using the stereolithography or SLA 3D printing process. This design part is fabricated from liquid resin. Initially, a tank is filled with liquid resin, then the build platform is immersed in it. A laser is triggered to the build platform and traveled to the specific area. The resin of the targeted area is solidified immediately and attached to the build platform due to its photopolymerization, and it forms a layer. Additive manufacturing makes it possible to achieve complex metamaterial fabrication. However, metamaterials fabricated by the SLA method shows poor mechanical performance, and this limits its ability to be a functional material. Researchers reveal that non-uniform solidification of the liquid resin during the SLA fabrication results in poor mechanical strength and degraded dimensional accuracy. This research focuses on improving the mechanical performance of the metamaterial using the post-curing process. The post-curing process can potentially alter the microstructure and refine the grains, which result in homogeneous structure and enhanced mechanical performance. The equipment used in this research is shown in Figure 1. Sam, would you like to continue with the experimental procedure?
Yes, I will. I'm sorry, I was muted. But in the additive manufacturing process, part degree orientation is an important factor that improves the print quality and the mechanical strength of the part. To find a suitable orientation, we have the type B specimen that we designed and printed and tested in 3 orientations, which are 0 degrees, 45, and 90 degrees. They're all shown in the figure below, figure 2. The mechanical properties, the material properties are characterized by performing standard tensile tests following the ASTM standards. All the type V specimens were printed using the same processes and went through the same post-curing conditions. This research shows this research tested at least 27 type V specimens to obtain the mechanical properties in the experimental setting. The weight, density, and tensile strength of the specimen are summarized in Table 1. The tensile test results are shown in Figure 2. And from the tensile test results, it is found that 90-degree orientation demonstrates the best strength amongst the 3 orientations. Next, the metal material have been designed from their corresponding unit cells, i.e., the circular unit cell. Each of them has a size of 50 millimeters length, 50 millimeters width, and 50 millimeters height. A low force stereolithography, LFS, Form 3 Plus 3D printer manufactured by Formlabs is utilized to fabricate the designed metamaterial at 90 degrees orientation. a total of 12 metamaterial printed and post-cured according to the table 2, which is below. The unit cells and their corresponding metamaterials is shown in figure 3. When it comes to the results of our experiment, the compressors test is performed on the metamaterial to characterize the mechanical properties. The compressive load continued to be applied to the metamaterial to the maximum capacity of the UTM. No obvious crack or catastrophic failures was observed during this process. The test results in the form of a stress strain curve was shown in the figure below, figure 4, which shows that ultrasound at 10 minutes at 60 degrees Celsius characterizes higher ultimate compressive stress, while ultraviolet waves at 30 minutes at 40 degrees Celsius show higher yield strength compared to other metamaterials. Now we codename this a little bit. Alt underscore 10M underscore 60 degrees indicates that ultrasound post-curing method was utilized for 10 minutes at 60 degrees Celsius. Even though the cross-sectional area, beam light, and the weight of these metamaterials are approximately equal, the post-curing methods affect the mechanical behavior significantly. Post-curing time and temperature also impacts the mechanical properties. The maximum yield strength is found for ultraviolet rays. The maximum yield strength are found for UV method is 0.08 megapascals. Oven approach was found at 0.072 megapascals, and the ultrasound techniques demonstrate 0.085 megapascals are reported in table 3, as shown at the side. In addition, 2 flat stress strain curves are noticed in the compression test results, which indicates they perhaps exist some possible errors while capturing the data. This project is still going on. The errors will be addressed by testing multiple replications of each combination. In conclusion, this research explores 3 different post-curing approaches to improve the mechanical properties of metamaterials. The mechanical properties are characterized by employing a standard compressive test. The experimental results show that 30 minutes at 40 degrees temperature combination provides the better results compared to other combinations for post-curing methods. In addition, the overall UV method performs better than the oven and the ultrasound techniques. This conclusion is drawn based on the results obtained from one sample from each combination, which may limit the verification of the same results. In this issue, we have addressed in future works. In this research, 12 parts in the 3 batches are printed, but only 10 parts are tested, as 2 parts were defective. Due to this complication of the part, sometimes print failures occur, which may not be avoided in the AM process. However, even though there are several limitations to the exits in this research, the main takeaway of the primary investigation is that the most post-curing methods are significantly affects the mechanical behavior of SLA 3D printing. Thank you.